What's up, guys? I'm Bruno at 254, and today we're going to learn about oxidation states. Welcome to our today's class. What do you need to know about oxidation? Basically, what is oxidation state? Oxidation state, also referred to as oxidation number, basically is the degree of oxidation of an atom in a given chemical compound, or basically the degree of loss of electrons. Oxidation state, therefore, is represented as either an integer, which means it can either be positive, negative, or even zero. But in some cases, you can get an average oxidation state of an element as a fraction. For instance, we have the oxidation state of iron in magnetite shown in a given formula represented as 8 over 3. But what are the rules that we need to follow in calculating oxidation states? These are very basic and these are very simple. First, we need to know that an element in its free form has an oxidation state of 0. Such elements are those you have come across the periodic table. This may include carbon, magnesium, potassium, lithium, sodium, name many of them. In their free form, their oxidation state is always 0. What if it is a compound or an ion? In such a case, the sum of oxidation states equals to the total charge of the compound or an ion. An example of a compound is the one represented in the equation in the chemical formula H2Cr2O7. We need to know how to calculate oxidation numbers. And the first example is calculating the oxidation state of chlorine in potassium chloride. The first thing you need to know is that potassium chloride is a neutral compound. Why? Because the net charge is 0. We don't have a net charge indicated by any sign in that chemical formula shown there, and therefore the oxidation state of potassium chloride is given as the oxidation state of that potassium plus oxidation state of chlorine, which should be equated to 0 since the overall charge is 0. Therefore, we know that oxidation state of potassium is +1 since it has an extra electron in its outer electron band. In that case, an element with an extra electron in its outer band is regarded to have a +1 oxidation state. Therefore, if we take +1 plus x, assuming x is chlorine, is equated to 0, we have x is equal to -1. Therefore, we have oxidation state of chlorine as -1. The second example is calculating the oxidation number of manganese in a permanganate ion. Permanganate ion is shown in the chemical formula above, where we can see we have an overall charge of -1. Therefore, the charge of permanganate ion is -1, and we know to calculate the oxidation state of any given element in that chemical formula, we have to equate it to the overall charge, which is -1. Therefore, we have oxidation state of permanganate ion equating to oxidation state of manganese plus the oxidation state of oxygen. Therefore, oxidation state of oxygen is -2, and we have oxidation states being calculated as X, where X is representing manganese plus 4 atoms of oxygen, and we have 4 times -2. Oxygen has 2 electrons remaining to fill the outer band. In that case, we have 2 extra electrons needed to make the element stable. In that case, we have 4 times -2, and that should be equated to -1, the overall charge. Therefore, we have X being +7. Therefore, manganese has an oxidation number of +7 in a permanganate ion. But how do we calculate oxidation number of a metal ion in a complex? A given example of a complex is the one shown there. We know the total charge of that complex is 0 since we don't have a charge indicated on the at the end of the chemical formula. Therefore, carbon monoxide is a neutral molecule. Therefore, oxidation states are given as X, which represents the Ni plus the 4 atoms of the four atoms of carbon or carbon monoxide. As we multiply 4 by 0, we get a 0, and then that means the oxidation number of the metal ion in this chemical formula is equal to 0. We need to know how to calculate oxidation state of something like chlorine in the chemical formula shown below. We know that the compound is neutral since it has a net charge of 0. Remember how to look at the net charge of a compound, and therefore we have 2x. What do you get 2x? We have 2 atoms of chlorine in that chemical formula. There we get 2 times x plus oxidation state of oxygen. Oxidation state of oxygen is, as we had said earlier, is -2. Therefore, we get 2x plus -2 being equated to 0. And therefore, if you divide both sides by 2, you get x being equated to +1. And therefore, you know that the oxidation state of chlorine is now +1. Thank you for watching. Please like, share, and subscribe. Bye.